All right, our next type is logarithmic equations. So if there's more than one log in the equation, then the bases must be equal. Okay, and so there's two types that we're going to look at, and it kind of depends on the number of log statements we have and where they are in relationship to each other. So the first type are equations that can be expressed as some log base of some number m equals a constant. Okay, or in other words, if I can get it to say log equals a number of some kind, then I can follow the expectations for this particular type. So some examples that we might encounter: log base 3 of x equals 4, ln of x equals 7, log of x plus log of 3 equals 4. And so notice in all cases, I was able to get the log on one side. Now, this last one, you got to think for a second. Because I'm adding logs of the same base, what property does allow me to use? And that allows me to rewrite it as 3x and bring it together as a product. So all of these different statements can be, again, simplified down to a log equals a constant. Okay. Now, what do we do when we see this? We are going to condense to a single logarithm using the rules of logarithms. Step 2 is we're going to rewrite the log equation as an exponential equation. So we're going to convert forms. Then we're going to solve and check all solutions do not make the arguments negative. Do not make the arguments 0 or negative. Okay, in other words, check that when we have an answer at the end, that it actually fits in the original log equation. We have a domain restriction on logs, and that logs, we cannot take the log of a negative or 0. Those are undefined quantities. So I want to just double check that when I get a solution, it's not asking me to do that. Okay, the second type, I scroll down here, the second type can be expressed as the log of any base of a number equals the log of another number. In other words, if I can get it to say log equals log, then I can apply this particular rule. So some examples where you might see this happen: log base 7 of x equals log base 7 of 42. The log of x plus 3 equals the log of 2x minus 4. And the log of x minus the log of 4 equals the log of x squared. Again, in that third case, that last case I just wrote, we have 3 logs, but I'm subtracting. And we've got a log rule that allows us to rewrite that. So I could rewrite that as a quotient, and then I get something that I can work with. Okay. Now, what do we do once we've identified that that's what we're dealing with? Step 1 is to condense to a single logarithm using the rules of logarithms on each side of the equation. So in other words, if I don't have it so it says log equals log, then use log rules to get it to say log on just a single log statement on each side. Number 2 is we're going to set the arguments equal to each other. Now the arguments, let me kind of come back here. These things inside the log, those are the arguments. That's what we're taking the log of each side. Alright, step 3 is we're going to solve and check all solutions do not make the arguments 0 or negative. All right, in this first type where we have log equals some sort of number, remember our first step is to convert it into its exponential form. So here I don't see a base. So if I don't see a base, it's always base 10. So in exponential form, it'd be 10 to the first equals x minus 3. In which case, now I can solve for x. So I'm going to add 3 to both sides, and so I get 13 equals x. Now, before I circle that and call my teacher over and say, I got an answer, I do want to check that it didn't violate domain restrictions. So when I come up, I want to take this x equals 13, and I just want to plug the 13 in, and just make sure that whatever it asked me to do, I get a positive number. So when I do that, I get 13 minus 3, which gives me 10. So we're good. X is 13 in that case. In the next example, we have log base 4 of x plus 3 equals 2. So I'm going to rewrite that in its exponential form. So the base of 2 equals x plus 3. Okay, so what is, let's see, that's 4 squared is 16. And then I want to subtract 3 off, and I get 13 equals x. So again, before I get too excited, just double check. So if I get 13 plus 3, that's a positive number. And so yeah, we're fine. We haven't violated any domain restrictions for the log. The next example, 3 ln of 2x equals 12. Well, I need to isolate that 3. Okay, so the easiest way to get rid of that 3 is simply divide both sides by 3. So that gives me ln of 2x equals 4. Now we got to remind ourselves, what does ln mean? Ln is really log base e of 2x equals 4. So now when I go to convert it into exponent form, I get the base, which is e, to the 4th power equals 2x. And I'm trying to solve for x, so I'm going to divide by 2. So I end up with e to the 4th over 2 equals x. And again, before I circle that and say I'm done, let's just double check we get a positive number. You know, e being to the 4th is, like 2.71 to the 4th, so 3 to the 4th over 2. It's a really big number, is what it is. So if I take a very positive number and I double it, well, I still get a positive number. So I haven't violated domain restrictions there. The next example, we have log base 2 of x plus log base 2 of x minus 7 equals 3. So we need to condense it to get it down to a single log. And since we are adding right there, then I can rewrite this as a product. So log base 2 of x times x minus 7 equals 3. And so now that I got it down to a single log, I want to rewrite it into exponential form. So I need a base raised to a power, so 2 cubed equals x squared minus 7x. Might as well distribute right there. And what is 2 cubed? Well, 2 cubed is 8. Okay, so now when I bring the 8 over, I get x squared minus 7x minus 8 equals 0. Sorry, there's a 0 there. And I want to try factoring if I can. It's quadratic. We're pretty good at quadratics at this point. And I can see, let's see, so it's got to be x and x, 8 and 1. And we need the 8 to be the negative and the 1 to be the positive. Let's see, that gives me negative 8x plus 1x. So that's okay. So we're good on that. And so what does x equal? X equals negative 1 and 8. Okay, so remember, before we get excited and circle both these, I need to check them. So let's take the negative 1. Already we got a problem. We're taking the log of a negative 1. So it violates domain restriction there. So x can't work. 8, on the other hand, I get x, or replace the x with 8. That's log base 2 of 8, so that's good. X minus 7 is 1, so that works. So our answer There's a nice little symbol. It's just 8 in that case. And I do like to see that you at least wrote the -1 and that you were aware to check it. Okay. Next example, we have logs on both sides, but I can move the log over. So that'll give me log base 4 of x minus 3 minus log of base 4 of x plus 3, all of which equals 2. And now that I got the logs on the same side, I can condense this. So log base 4 of, since we're subtracting, that means we're going to divide inside the log. So that's x minus 3 and x plus 3, all of which equals 2. Okay, so now I got it down to a single log, and I want to convert forms. So I need the base, in this case 4 raised to the second power, equals that lovely fraction. Well, now what? Well, what if I multiply both sides by x plus 3? Because that's what's going to get rid of the denominator there. So the denominator divides out in that case, and we're left with, 16 times x plus 3 equals x minus 3. And let's distribute that, so 16x plus, 16 times 3. Yeah, maybe you want to take a calculator out, but let's try it in our heads real quick. Well, 10 times 3 is 30, and 6 times 3 is 18. So 30 plus 18 has got to be 48. All right, and then we want to get like terms on the same side, so we'll subtract x on both sides. We'll also subtract 48, so we can move that over. And so I get 15x equals negative 51. And now what? Now we want to divide by 15. Okay, so I temporarily get x is negative 51 over 15. Now what? Okay, so let's check it. It's a negative number. When I go to evaluate it, see the problem with that x minus 3? If I take something that's negative and I subtract another 3 from it, it's still negative. So in that case, our answer is not going to work, and that's the only answer that mathematically showed up. So I would just write no solution in that case. Even though we found a number, it's not going to work because it violates domain restrictions. All right, the second type of our log are things where I can get it to say log equals log. And this is kind of similar to if there's a common base. Once we get the outside pieces to match, then we just set the inside pieces equal to each other. So in this first case, log base 2 of 5 plus log base 2 of x minus 3, I can bring those two logs, I can condense them together. And that's the product of 5 times x minus 3 equals log base 2 of x plus 5. And now that I've got the outsides to match, I want to get the insides to match too. So my equation is going to look like 5 times x minus 3 equals x plus 5. All right, so now I just want to use my algebra skills. So we'll distribute the 5 in, so 5x minus 15 equals x plus 5. We want to subtract x, get it over there. We want to add the 15. And I just realized that my 5 all of a sudden looks like a 15, and it should still be a 5. All right, so that gives us 4x equals 20. And when I divide by 4, I get that x is 5. Okay, so before I get excited, I want to check it. And 5 minus 3 gives me 2. It's positive, so that'll work. And 5 plus 5 is 10, so yeah, that works. X definitely is 5 in that case. In the next example, we've got ln of x minus 1 plus ln of x equals ln of 2x. So I want to rewrite that as a product. So ln of x minus 1 times x equals ln of 2x. And now that I got the outers to match, I want to set the inners equal to each other. So that would be x minus 1 times x equals 2x. And let's distribute that in. So that would be x squared minus x equals 2x. And so if I subtract off the 2x and bring it over, I get x squared minus 3x equals 0. And we've seen enough quadratics that hopefully we recognize that this is something we can factor. So that would be x times x minus 3. So I get x is 0 and positive 3. And so before I circle anything and get all excited about it, let's see. So 0, 0 minus 1, I'm sorry, right there, 0 minus 1. Oh, I already get a negative 1. It's going to violate the domain. So 0 cannot work. Let's try 3. So 3 minus 1 is 2. So we're good. ln of 3, well, it's positive. ln of 2 times, that's great. We get positive numbers all over the place. So x is 3 in that case. And in our last example, I can see that I can rewrite the right side. I can change that into a divide. So x plus 9 over x. And now that I got the outsides to match, I'm going to set the insides equal to each other. So that's x plus 1 over, equals x plus 9 over x. And I want to divide both sides by x. I'm sorry, not divide. I want to multiply both sides by x. So on the left, I get x squared plus x equals x plus 9. All right, now what? We're going to subtract. So subtract x minus 9. So minus x minus 9. And that gives me an x squared. The x's cancel out, but an x minus 9 equals 0. And that's factorable. Hopefully you caught that x minus 3 and x plus 3. So I get solutions of 3 and negative 3. All right, so let's check it and make sure they don't violate domain restrictions. So 3 plus 1 is 4, we're good. 3 plus 9 is 12, we're good. And so 3 works, 3 is fine. Negative 3 plus 1 is negative 2, does not work. So negative 3 doesn't get to come, but positive 3 does.